Hello, this is Priyanka. This is Priyanka Katare, Assistant Professor in Department of Electronics Engineering, Walchand Institute of Technology, Solapur. Today in this presentation, we are going to see one of the important algorithm in the artificial intelligence is that the A star algorithm. Learning outcome. After completion of this session, students can learn the concept of heuristic search and they can develop analytic skills to evaluate the efficiency and effectiveness of the A star algorithm compared to the other search algorithms. So in this whole session we are going to see search techniques, A star algorithm, working of A star algorithm, efficiency and performance of the A star and its application. So first of all, we're going to see search technique. We know that in the artificial intelligence, some real life problems we are going to solve through the search operations. Search operation is important because it gives results. It searches something. Through the search operation, we are solving some real world problems. So there are basically two types of search techniques in the artificial intelligence. One is the uninformed search technique, that is also called the blind search technique. In this technique, just it works without using any additional information about the problem. Means what? Just it's trying to retrieve all the possible paths present in that map, present in that network or the graph. It will visit each and every node or vertex present in that map, in that graph. So its example is that we can see in the diagram. In this diagram, that is breadth search first search and depth first search. In this both technique, we can see breadth first search is used when we want to search very brief breadth, like that level by level we are traversing. First we are visiting at the root node, after that we are visiting to the next level, all the nodes. After completion of all the node present in the next level, we are going to the next level. In each and every level, every vertices we are visiting and traversing, and just we are comparing whether that the just we are reached a goal state or not. Means we are comparing every vertex with the goal state and going further until all the nodes have completed or we have got a goal state. So this is the blind search. Next example of this blind search or uninformed search technique is that the depth first search. It searched deeply. It searched from the root node to its first successor node, again that successor of the successor node until there is no further node. We can see in the graph there is zeroth node, first node and next further third node. Further there is no any children node of this third node, means it will next backtrack, it will come its parent node. If there any successor of that parent node, yes, that is 4, again it go to that fourth node. No any successor of this fourth node, again it will do backtracking until it will get root node. Again there is further successor. Means what? It will visit each and every node present in that graph, but it uses depth first search method. The both example we can see here, means we are visiting each and every node in that graph, so there is guarantee of getting the goal state. So that is called the completeness, that is called where there is a guarantee of getting the goal state and there is guarantee of the minimum path. That is, we can say in the we also as a result we will get the minimum path in this technique. This is the next search technique, that is a heuristic search technique, or that is called the informed search technique. As per the name, in these techniques we have the information related to the problem called heuristics to guide the exploration of the search space. We know that search space means where we are going to search that particular goal state, in which Means all the we are either searching, there are possible solution space, is there possible solution which is optimal, or there are some search space. Means what, suppose there is a tree and we are searching for particular node, means that whole tree we are considering as a search space. So this algorithm uses domain specific knowledge to make information decision about which path to explore in order to reach the solution. Means as we seen in the previous we have seen that just blindly it is searching, it is traversing by breadth first or depth first, but is visiting each and every node present in that node, in that graph. Suppose that graph is contains several node, means it will visit each and every node until it will get goal state or until all the node have completed. But here in the heuristic search, some we have knowledge, and using that knowledge, it is in at every step it is checking whether all we are checking, we are going for minimizing the search space. Okay, so here for that, for minimizing the search space and minimizing the whole, we are avoiding all the nodes, just we are going closer and closer to the goal state using some heuristic function and evaluation function. Heuristic function is, it is provides the estimation of the cost or the distance from given state to goal state. Suppose we want to go to, as a traveler, suppose we want to go to any city, means so we want to check whether which path is better for us, which path gives us less, if reaches in less time, or which gives us less cost. In the networking also, which through which path we will get the less cost. Okay, so heuristic function gives us from the particular state to the goal state what is the estimated cost we require. Suppose from n node, from source node to n node, and from nth node to the goal node, what is the cost from nth node to the goal node? Okay, that gives us the heuristic function. Okay, given state of the goal state. Evaluation function, this function provides the actual cost we require from source state to the goal state. Means actual overall, that means we know that the heuristic function gives from that intermediate node n to the goal state, but this evaluation function gives us the cost from source node to the goal node. Means the actual total cost we get from the evaluation function. So it gives that it is that actual cost incurred so far, known cost, and the heuristic estimation to determine priority of particular path. The purpose, what is actually A star algorithm? Why it given that name is A star? Because that A means what? That is A star. Its purpose is that it efficiently and guaranteed gives us the optimal path. Means what? Its purpose of A star algorithm is to provide the guaranteed optimal path from source node to the destination node using some heuristic values and the distance from source node to some intermediate node. Okay, A star combines the benefits of both completeness and optimality. Means completeness means it is guaranteed we will get a goal state. Means we will guaranteed if that goal state is present in that map, in that graph, means we will guaranteed that we will reach to that goal state. And optimality means we will get one optimal solution. We will get optimal means what? That is closer to the best solution. That is called the optimal solution. And A star algorithm guarantees to give the optimal solution. It is widely used in various applications where this A star algorithm is used in the pathfinding, in the map, in the robotics, and in the artificial intelligence, where we are finding most efficient, or we can say the optimal route, which is very essential in these applications. References of this session. Thank you.